Hi class, let's take a look at example 3. And in example 3, we're looking at, well, a total of 12 degrees of freedom, actually 11 degrees of freedom, a standard deviation of 2.8, and the values of C is equal to 0.99. So let's start with the critical values. And on our critical values, we're going to be looking at the following region. And then we technically have the chi-square value on the right. So this one on the right, and then the chi-square value on the left. And as we look at the regions, this portion here and this portion there. Let's take a look at the actual value of alpha. So because the value of C is 99, your values of alpha, it's 0.01. So that means that alpha divided by 2 will be 0.005, which in turn means that this tail has 0.005 area. This middle portion is 0.99, and this will be 0.005. As we look at the total area towards the right, you're going to have that the one on the right has 0.005. The one on the left has 0.99 plus 0.005, which is going to give us 0.995. So we're looking at 11 degrees of freedom, and then, well, total area for the one on the right, 0.005, the one on the left, 0.995. So let's take a look at the table. And 11 degrees of freedom, 0.005 would be 26.757. So this one, it's going to be 26.757, and then 995, 2.603. So this one would be 2.603. Let me double check that one. 603. And let me just write them to the side. So in this case, the critical values are going to be the one on the left, approximately 2.603. The one on the right, 26.757. And we're going to be evaluating n is equal to 12. And the standard deviation of this one to be 2.08. So all of this information we're going to evaluate into the confidence interval. The first portion is just to find the approximate critical values that we're going to be using. Let me pause here for a minute, and then we'll move on to the calculation. Okay, let's move on to the last portion. And in this case, we're just going to jump into the formula. So this would be the 99% CI for the values of standard deviation sigma. It's actually going to be bounded by the following formula. So we're going to have the sigma, it's bounded by the square root of n minus 1, technically s squared, and then the chi-square value on the left, then square root n minus 1, s squared, then the chi-square value on the right. Let me just confirm the formula. And then the values that we're going to be evaluating here, it's going to be that sigma is going to be bounded. And then this one's going to have the square root. So this one's going to have 11, then 2.08 squared over the one on the left, 2.603. And then square root 11, 2.08 squared over the 26.757. So sigma is going to be bounded by the following values. Please evaluate those. Okay, so on my upper bound, I'm getting 4.2759. So 2759 rounding to 4. On the lower bound, we're getting 1.3336 if we round to 4 decimal places. Let me double check. 2.08 squared, 2.603, 26.757. That's actually it. Let me just write it out as a sentence. This would be the 99% CI for sigma happens to be around 1.3336 to 4. This looks like a 9. Let me fix it. 4.2759. And then let me double check the units. I believe it's seconds. So this would be seconds on the units. That would be our final answer. Remember that your final answer has to have the interval. In this case, your interval, it's technically expressed here. So we're saying that the population standard deviation, it's likely to be within those two values with a 1% error. In this case, alpha represents your error. That's actually it for this one.